Generally speaking, gambling is a bad bet. Lotteries, slot machines, games in general are designed to take in more money than they pay out. And even if you get lucky and you win a few times, chances are in the long run you're going to lose unless you have some system to subvert the very structure of the game. Today, let's consider a game called Lucky Sevens. And it seems like a good idea at first, but as usual, it's a big loser for the gambler in the long run. The game's pretty simple. You roll a pair of dice. If the sum of the two dice equals 7, the player wins $4. Otherwise, the player loses $1. Now, some slimy casino guy is going to tell you, hey, there are so many ways to win. You can get a 1 and a 6, you can get a 2 and a 5, and so on. But if you sit down and you look at it mathematically, of course, it is revealed that there's not enough ways to win to make the game actually worthwhile. But of course, lots of people, their eyes just sort of roll over into the back of their heads as soon as anybody starts talking about math. So what we're going to do today is write a quick little program that demonstrates how futile, how pointless it is to play this game. So if that's our goal, let's think about what exactly we're going to have to do to make this program a reality. We'll use a random number generator to write a program that simulates the game. So the program is going to ask the user how many dollars she or he has, and it'll basically play the game over and over and over again until all the money's gone. And then it's going to display how many rolls we actually took. We'll also keep track of the maximum amount of money that the player ever had, and in doing so, we'll demonstrate that getting ahead at some point doesn't actually forestall the inevitable outcome of losing the game. Below, you can see a proposed interface, us prompting for how much money the user has, in this case 100, and then we would display how many rolls it took to go broke and display when exactly, which is to say after how many rolls the user should have quit because they were at their highest point. Here, looks like it was after they had earned $13 and were at a total of $113 after 47 rolls. Here you can see some pseudocode for this program. We start by asking the user how much they have in order to gamble. We create a counter representing the number of rolls overall. We also create a variable called max, maybe, that holds the initial amount, because at the start of the program, that's the most money we have, and the count at the maximum, which means the number of rolls at the current maximum, which will start as 0, because we start having taken 0 rolls. Then, as long as we have any money left, we'll add 1 to our roll counter, roll the dice, which is actually get the random numbers, and then we'll do a little bit of math. We'll say, hey, if the dice add to 7, we'll add 4 to the gambler's total, and otherwise we'll subtract 1. Then we'll check to see whether we've hit a new max. And if we have hit a new maximum, well, then we'll remember that maximum. We'll store that into our variable holding the maximum amount of money, and we'll remember how many rolls it took to get to this point, to get to this new maximum. Finally, after that loop is ended and we've run out of our money completely, we will show how many rolls we had, what our maximum was, and how many rolls it took us to get to that maximum. In other words, when we should have quit the game. So let's take a look at some of the code. We start here with just the comment at the top of the program explaining what's going on. We have the rules of the game. We have the inputs. We sort of explain the computations that we're going to go through over the course of the game, and we explain the outputs. I encourage you, pause this video and read through this comment right now, or just open up the PDF from the website. Moving on, we declare our class and start up our main method. We make a new scanner object and a new random object, which we know we're going to use. And then we declare all the variables that we plan to use in this program. That means variables that are going to hold our 2 die rolls, that'll hold our initial amount of money that the user has to begin with, that'll hold the number of rolls that we take overall. We have max dollars, which will hold our current max, the most money that the user had at any particular moment, and we have a variable count at max, which just stores when that maximum was achieved. So you'll see these were all declared up at the top of the program. And now we go ahead and implement the rest of our pseudocode. You can see the little section comments here with the above each chunk of code. We request the input, we read an int from the user, store that in dollars, and then we initialize all those variables that we were working with before. As long as we have any money left, so as long as dollars is greater than 0, we will do a roll. That's what we see here. We'll calculate whether the roll that we just got was a winning or losing roll, And if necessary, we will recalculate what our max was and how many rolls it took to get to that max. And we'll keep doing that over and over again until there is no money left. Finally, at the end, we will print our final results, including how many rolls overall they took, how many rolls they were at their max, and how much they had when they should have quit at their max. Take a few minutes, pick through this code a little bit, either in the PDF or in this video, and just make sure you feel good about everything that happened here, particularly the looping, the conditional logic, and the arithmetic that happened. If you're new to programming, you might want to spend a little time making sure you understand the sequence of everything that is happening in that while loop, particularly, paying attention to different cases. Like, what if I win money and it's my new max? What if I win money, but it's not my new max? Things like that. That's it for today.